we take a look at this, right, my mean is 100. If I add a standard deviation in either direction and subtract a standard deviation, I get to 85 and 115. So approximately 65% will fall within one standard deviation, so that's between 85 and 115. And then if I go 2 standard deviations in either direction, this is minus 2 standard deviations, this is plus 2 standard deviations, then that's about 95% between 2 standard deviations. So that's between 70 and 130. So about 95% of the population will have a score between 70 and 130. If I go 3 standard deviations, 55 to 145, then a lot of people, that's within 3 standard deviations, about 99.7% of the population, almost everybody will have a score between 55 and 145. Okay, we're done with that one. Pull out your new one from today, your new notes. We're going to do 3.3. Measure the relative standing in box plots. So first of all, you guys remember means and standard deviations? What are the symbols for those? 15 seconds with the neighbors. Figure out population mean, population standard deviation, sample mean, sample standard deviation. What are those symbols? If you're not talking to your neighbor, I'll probably call on you. All right, Patrick, give me one of them. Mu, what's mu? Which mean? Population mean is mu. Okay, Derek, give me another one. X bar, what's that? Mean for the sample. Eduardo, give me another one. Phone a friend if you want, quickly. I need one of the standard deviations for population standard deviation or the sample standard deviation. Give me the symbol for one of those.
S.
Okay, S. Which one is that one? Which one is that one? S is the sample.
Standard deviation of sample.
Standard deviation of sample. And then the last one, sigma. That's a population standard deviation. Great. With your neighbors, figure out which of these are statistics and which ones are parameters. 15 seconds. Again, I will call on you if you're not talking to your neighbors. Sterling, are you talking to him? Okay, guys, which ones are statistics? The sample. So X bar and S are statistics. Which ones are parameters? U and sigma are parameters. So if I say the parameter, don't freak out and be like, what? Say, oh, that must be one of the population things like mu or sigma, right? If in this class, this is a statistics class, so most of what we're dealing with are S's and X bars. But the word parameter should not be this foreign, crazy thing for you. It should be, oh, they must mean the Greek letter thing, like mu or like sigma or something like that. Find one that makes sense for whatever the problem is. So that will come up. All right, so now we get to the important stuff. So here's an example, 55 plus or minus 10. That kind of means that the mean is 55, give or take 10, right? Standard deviation is 10. So what's my mean? Everybody, what's my mean?
55.
How far is 60 from the mean? 5. Great. What's my standard deviation? How much is the standard deviation?
10.
So, how many standard deviations is 5?
0.5.
Half. Right? 0.5. Does that make sense? Half of 1? 0.5. How do we find that? If I have 24 inches, 24 inches, and I want to know how many feet that is, what do I do?
Divide by 12.
Divide by 12. Why do I divide by 12?
That's how many inches are in a foot.
That's how many inches are in a foot. So if you want to convert something from inches to feet, you divide by how many inches there are in a foot. If I want to, so here, if I wanted to know how many standard deviation something is, say this is 5 pounds, and standard deviation is 10 pounds, I want to know how many standard deviations it is, I would divide by whatever, however many of these is in a standard deviation, so I can get it in standard deviations. Does that sort of make sense? If something is 5 inches and there's 10 inches to a standard deviation, then I divide by 10, so I get it in standard deviations. Same as, you're familiar with doing it in feet. It's very similar to the same thing. Divide by however many are in a foot. Here you divide by however many are in a standard deviation. There's 10 of them in a standard deviation, divide by 10. How about 40? Is 40, how far is 40 from the mean? 15. Everybody on board?
Yeah.
Mean is 55, 40 is 15 away from it. Is it above the mean or below the mean? Below the mean, so we're going to make it negative 15. How many standard deviations is that? Divide by 10, because that's how many is in a standard deviation? Negative 1.5. These are z-scores. Z-score says how many standard deviations you are above or below the mean. So here, I'm 1.5 standard deviations below the mean, so my z-score would be negative 1.5. Here I'm 0.5 standard deviations above the mean, so my z-score would be positive 0.5. I could take off the O. I don't need that there. So this part right here, this first part, we're going to read this part together because it's super, super important. You guys ready? We're all going to say it together. Ready? 1, 2, 3.
The z-score represents the number of standard deviations
Makes sense? You need to know this because it will. Why do I make you say this? Not just because I'm a jerk, but because it's really, really, really important. Z-scores come up in chapter 3, in chapter 6, in 7, 8, and 9. You're going to see them all over the place the rest of this course. You have to know what a z-score is. And people get really confused about what it is and start making it other things. It's just, how far are you from the mean? Here's the mean. Here's me. How far am I away from the mean? How many in standard deviations? Right? How many standard deviations am I away from the mean? That's all it is. It's a measurement of if I went standard deviations over, how many standard deviations would it take to get to me? For any one specific variable, each value has exactly one z-score. Each z-score corresponds to exactly one value. So here's an example. Someone has an average height of 66 inches and a standard deviation of 4 inches. So here's 64 inches. Standard deviation is 4 inches. It would have a z-score of negative 0.5. Everybody on board with that? Also, if I said, well, which value has a z-score of negative 0.5, I'd say, oh, well, negative 0.5 corresponds to a x value of 64 inches. So kind of everything will have an x value and a z-score value. You can kind of think of it, right? What's the z-score for 66 inches, by the way? Does that make sense for folks? How far is 66 away from the mean? 0 from the mean. It is the mean. So it should have a z-score of 0. Making sense?
Yeah.
Oops. I want that to be pink. Everybody on board? So whether I say z-score of 0 or x value of 66 inches, it still means the exact same spot. It means right here. How do you compute the z-score? You can do exactly like we did. You take the value, subtract the mean. That way, if it's more than the mean, it should be positive. If it's less than the mean, it should be negative. And then you divide it by a standard deviation, so you get it in terms of standard deviations, in SDs instead of in inches.
So the z-score of 60 in that last problem would be 0.5?
The last problem is 64.
The last problem says how far 60 from the mean, so I put 60.
Yeah, so
0.5.
60 had a z-score of 0.5, exactly, in the first example. Perfect. You guys should write this in under your notes here. If it's for a sample, the z-score is, let me write this in next to this one, x minus x bar divided by, what's my standard deviation for a sample? S. Good. Did everybody write that into your notes? Physically write it in there. Like, don't just think about writing it in there. Actually write it in there. Take every x value, subtract the mean, divide by what a standard deviation is. That gives you your z-score for that value. How do you interpret them? Okay, so again, we talked about how if a z-score is less than the mean, it should have a negative z-score. If a value is above the mean, it should have a positive z-score. Typical values, we are 95% of our data lies within how many standard deviations? Do you guys remember? We just did that. 2 standard deviations. So here's my mean. If I go 2 standard deviations this way, that's an ordinary value, right? That's kind of the borderline of more ordinary values. What's the z-score here if I go 2 standard deviations this way? Negative 2. Right? If I go 2 standard deviations away from the mean, this way I'll have a z-score of negative 2. If I go 2 standard deviations this way from the mean, it'll have a z-score of what? Positive 2. So between negative 2 and positive 2, those are typical, usual z-scores. If my z-score is less than negative 2 or greater than positive 2, then those would be unusual z-scores. Is everybody on board with that part? Because my z-scores, within 2 standard deviations, means a z-score between negative 2 and positive 2. Beyond that, then that's in the unusual range. All right, so let's take a look at this one. Here's an example. Bless you. Well, we're not hold on yet. Justin, go ahead.
Two women in a soccer team have a bell-shaped normal distribution with a mean of 164 centimeters and a standard deviation of 7 centimeters. Hold it.
Yeah.
Candace has a height of 178 centimeters. Is she above or below the mean?
You can stop there, thanks. So Candace has a height of 178 centimeters. Is she above the mean or below the mean, guys? Above. What's the mean? Great. So she's above the mean. How far above the mean is she?
14 centimeters.
Yeah, 178 minus 164, 14. How many standard deviations is that? 14 divided by 7, 2 standard deviations. So her z-score is positive 2. Everybody follow that part? Yes, no? I can put centimeters in here, that's probably better. All right, Jenny has a height of 169 centimeters. See if you guys can figure out what her z-score is. So figure out how far she is from the mean, and then divide by standard deviation. So what's her height? What's the mean? What's the mean?
164.
164. What's the standard deviation?
7.
7. Yes, it is.
More right now. It's okay.
Okay, so her height is 160, 169. What's the mean? 164 divided by standard deviation. What's that? 7 centimeters? 7. So you end up with 5/7, which is about 0.714.
Yes, ma'am.
And we'll go 2/6. Well, that's fine. Usually we round it to two decimal places. Laura has a height of 152 centimeters. What's her score?
164 minus 152 divided by 7.
Yeah, find it, do it.
1.7.
X minus X bar over S. The X is whatever you're trying to find, right? Laura's height.
It's the same number. Oh, it's 1.7.
The,
It's not negative.
well, you guys have all these great
The
clothes.
first one?
What's my mean again?
Oh, I know.
Mean of 164, standard deviation of 7. So 152 minus the mean, 164, divided by standard deviation of 7, negative 1.71. Right? Yes?
Yep.
Because it's less than the mean. If you're less than the mean, it better be negative.
Values first. That's fine. I got that. Makes sense.
I can do the step in between. It's negative 12 over 7, negative 1.71. Okay, everybody good with that part? Great, we still have a fair amount covered.
Yay.
All right, you guys do Steve. Do the Steve sample, example. Literally, see if you can do it in 60 seconds, that'd be ideal. Yes.
What?
That's usual. Yeah. And that was 1.5 and wait, go for Oh, 2.6. Oh, okay.
So we got Steve's Z-score, is that unusual or
Kind of unusual, probably. It is 68%. Yes, I think so.
Okay, so Steve's height, 63.7, minus the mean. What's the mean?
67.4.
67.4. Divided by the standard deviation, what's that? 2.6. What'd you guys get? Negative what?
Oh, so negative 1.42.
1.42. Good deal. Is his height unusual or usual? Usual. Why? Because it's within 2 standard deviations. Does that make sense?
You just circled unusual.
Oh, thank you. Usual. Within 2 standard deviations. Thank you so much. All right. Good? Great.
So it'd have to be between 4 and 5.
It had to be more than 2 or less than -2 to be unusual.
Okay.
Now, the percentiles. It's the last thing we're going to cover today. 5% or less. Oh yeah, so the guideline for unusual at the bottom of your page, 5% or less, right? That's our guideline for unusual.
Yeah.
Haley, do you want to go and read?
Percentile is the measure of location. There are 99 percentiles,
P1, P2 up to
what?
P1 and P2 up to
Up to P99, which divide a set of data into 100 groups with about 1% of the values in each group.
Great. Those are percentiles. So this is how you find a percentile. Percentile is the percent of people in the group that you beat. So wherever your score is, you count the number of people that are less than you. And you figure out what percent of the population they are. Right? So you take the number that are less than you, divide by the total number that are out there, that's your fraction, and then multiply by 100%. That's your percentile. Let me give you an example. This is not yours, this is mine, so this is not the same one that's on your sheet. So 23 chips. I find the smallest 23, because I can't take this one, because all these guys are not less than 23. You guys see what I'm saying? So here is the smallest 23, the bottom 23, so then I know that all of these are less than it. Everybody on board? How many of them are there? There are 10 of them. 10 out of how many? 40. 10 out of 40 are less than him. I write that as a percent, multiply it by 100%, and I end up with 1/4, 25%. 25% are less than 23. So this is the 25th percentile. Okay? It's the percent that are lower than you are. So everybody do your example for 25 chips, which is the next one on your sheet.
There's 10.
Give me a little wave if you're done. So just need a little more time. There's the lowest 25. All right, so how many are less than 25? 22. 22 out of how many?
40.
40. And then you're going to change that into a percentile. So 22 out of 40 is 0.55, that's 55%. So it's the 55th percentile. You guys need to chat with your neighbors about this?
No.
All right, good. So the last thing we're going to talk about is converting the other direction. So, this is the opposite. Where does it come from? We just had something where we said your percentile is equal to the number of people lower than you, dividing by the number of people there are, times 100. So how do I get from here to there? If I want to solve for L, I'm going to multiply by n and divide by 100, both sides. So then these guys cancel out, the n's and the hundreds cancel out, and you're left with L is equal to k times n over 100. That's where this comes from. Where L is, this is actually wrong. L is really the number of people lower than you. Think of it that way. The number of people that you are above, that are less, the number of people that are lower than you are. K is the percentile. N is the number of people that there are. So if you kind of read your directions are actually the cleanest thing. To find L, divide k by 100, multiply by n. That represents the number of values that are lower than your value. Go to the next whole number to find the position you want. Here's the problem that we run into, is these are meant to be in data sets that are hundreds and hundreds of people. So unfortunately, your book and the last textbook we used in this class and the Excel and TI calculator, those all have different ways of calculating this. If you're talking about hundreds and hundreds of items in a data set, they all end up being basically the same. If you're talking about 10 or 20 things in a data set, then all of a sudden, then it makes a difference. But it's not meant for things that are small. However, to make things useful for you, we need to make them smaller sets so you guys can kind of work with and wrap your heads around. So it's a little bit annoying that it doesn't work perfectly for what we're looking at. So I'm not going to emphasize this a whole lot, but I am going to go through it. And you might have one homework question on it, maybe. I don't think so. Certainly you might, but it won't be on the exam. So let's go and look through this. So here, 25th percentile, put them in ascending order. 25th percentile, so that means that my k is 25. So L is equal to 25 over 100. Multiplied by how many items I have. I have 10 items. So that ends up being 2.5. So that means that I beat 2.5 people. If I beat 2.5 people, then I am the third person. Does that make sense for folks? So that's going to be 5. Because 2.5 is going to come in between the 3 and the 5. If you are the, sorry, this number's in the wrong spot. If you are the third person, you beat all the way up to the 2.99 person. You beat all of them. So we will look at this a little bit more later, but now I need to hand out your exams. You had a bunch of people